In this video tutorial, I will show how to split the data into features and labels and how to create training and test data sets. For this process, I will be using pandas and scikit-learn. For this video tutorial, I assume that the previous steps are done, like setup environment, Jupyter Notebook guide, the data load and analyze, and model choose ML model. If not, please go and check it. The concepts of features and labels, as well as training and test data sets, are crucial for machine learning projects. This video tutorial can be treated as a separate one or as a part of the larger one machine learning workflow, and in this case, it will be the third step: split the data, features and labels, training and test. To split the data, we need to have a data set. I will be using Kaggle like in the previous examples. I search for the house price prediction data set, and I will pick the one with the highest relevance. And I can see that on the right side there is the house price data source, and I will download the train one and then put into the folder of the project. As we can see that the downloaded file is in the project house CSV. As I mentioned before, we will be using pandas and scikit-learn. So now I need to install scikit-learn library, scikit-learn, and I need to go to console. To make sure that I'm using the right virtual environment, I type source bin activate and check the Python. Which Python? Yes, and that's the right environment. So now I need to install the scikit-learn from requirements.txt pip install -r requirements and hit enter. The previous libraries modules are installed, so now it will install only the scikit-learn. So everything is installed properly. Now I need to get back to the, and in the notebook, what I need to do is import pandas, tab for autocomplete as pd, shift enter to run. And now I need to df house pd.read autocomplete tab csv data / tab for autocomplete house, shift enter, enter, and I can print this house, shift enter, and do some sanity check. So the first record, which is ID 0, is 1, 60 RL 65. And looking in the CSV file, 160 RL 65, and it looks good. So now I will split this data into features and labels, but before doing that, I need to introduce the concepts of the features and labels. I've prepared a document where I describe the features and labels. In short, the features are the columns, for example, in CSV file, that the machine learning model will use to predict the labels. So the labels are the desired results. So reading the description from this document, features individual measurable properties or characteristics of data used as an input to the machine learning model. So the role, this is the input to the model, and it is important that this is an independent variables. An example of features for predicting house prices: square footage, number of bedrooms, location. And the label, the value or outcome the model aims to predict or categorize based on the features. So this is the output that the model predicts, and this is important. This is the dependent variable. An example for predicting house price, the actual house price. And below, this is the small data set where we have the area, bedrooms, location, house age, and the price. So the price is the label, and the other columns are the features. So when we look to our data set, the columns doesn't look the same. That's simple, but I will show you that the data set was from the house price advanced regression techniques, and there is an data tab, and all the data fields are here described. So this is the process of exploratory data analysis, but I won't be covering it in here. So now we know what the features are and what's the label. So for our example, we can assume that all columns are features and the last column, sell price, is the label. So these columns are the ones to predict the last one, the sell price. To split the data into features and labels, I will use pandas and this data frame. So in here, I will type x equals df. X is the common name for the variable that holds the features. And now I will use the drop method and need to put the name of the column with the label, the column that I want to remove from this data set. So, and I need to add axis 1. So this x value will contain all the columns except the sell price. So I hit Shift Enter and X Shift Enter. As you can see on the right, there is no column sell price. And now I need to create a labels. The Y variable is the common name for the variable that holds the label. And like the previous one, df house, but this time I will select the sell price column because that's the label, and I will Y. So in here we have only the house prices. I will clear the outputs to show how it looks. So simply we need features and labels, and the Y and X are the common names for the variables. X are the features, Y is the label. X is the columns that model will predict the Y value, in this case the price. I added the comments to be clear which variable holds which values. And now I need to split this data into training and test datasets. But before going into code, I need to show the theory behind the training set and test set. I will be splitting data into training and test set, and I will skip the validation. But in the context of machine learning, data splitting is crucial for evaluating model performance and preventing overfitting. And typically it divides into 3 sets. The training set, this subset is used to train the model. It contains the majority of the data, and the model learns patterns and relationships from it. Test set, this final subset is reserved for assessing the model performance after the training and validation. It provides an unbiased evaluation of how the model will perform on unseen data. In here I'm skipping the validation set, but this set is used for tuning the model, hyperparameters, and making decisions about the model architecture. So this three-way split helps ensure that the model generalizes well on the new data. When we say that the model generalizes on new data, the test data set, it means that the model can make accurate predictions on unseen data, the data set, that it was not trained on the trained data set. Splitting the data sets works in machine learning like studying for exams. So in here we have machine learning model. The training phase, the train set, the model learns from labeled data. In student, learning process, training phase, homework and practice. The student studies by solving practice problems. The testing phase for the machine learning, the test set, the model predicts on unseen data. So for students, the testing phase, this is the final exam. The student takes an exam with unseen questions. So the goal for machine learning model is to learn patterns to make accurate predictions on new data. And for student, understand concepts to answer new questions correctly. So in here, worth mentioning is that it's really important to keep the training and the test set separately, because we don't want the student see the final exam before he even take the homework or practice. So the same case is for the machine learning model. We don't want the model see the final data before he even train. That it leads us to the common pitfalls, both for models and students. The overfitting, memorizing. The student memorizes answers but struggles with new questions. Underfitting, lack of learning. The student doesn't study enough and performs poorly. Good generalization. The student understands the subject and applies knowledge to the problem. And we know that the generalization, when we say generalization, that the model generalizes on a new data, it means that the model can make accurate predictions on unseen data. But there is another problem. What if the student knows what the test dataset will look, because the train dataset was split into the same parts as always? So in here, the same problem is for the machine learning. And in here, we introduce the concept of cross-validation. When we split the data sets differently for different approaches, defaults. So rather than performing a single split on the data, cross-validation splits the data multiple times in different training and testing subsets. The most common approach is k-fold cross-validation, where the data is divided into key equal size folds. So now we know the theory behind the concept of splitting the data into training and test set. Now let's code it. To do that, we will be using scikit-learn. All we need to do is just to import sklearn model selection, import train test split. Now we will use this function, train test split, pass the features, pass the labels, decide about the test size. It's in percent. So 20% of this data will be test set and 80% of this data will be the train set. To see how to use this function and what it returns, I will move to the name of the function, Shift Tab, and see the documentation, the parameters, and the most important in here is what it returns. It returns the xtrain, xtest, ytrain, and ytest. So I will just copy it, put it in here, Shift Enter to run the cell. So it looks like it didn't do anything, but when we see this xtrain and Shift Enter, we can see the number of rows, and the same with the xtest, different number of the rows. Let's check if it divided correctly. To make it quicker, I've prepared the code. I will clear the output. I've added the comments as well. And in here I will paste the code and run it, Shift Enter. So as we can see, it's printing information about the length of splitted data sets, so the number of elements in entire data set was 1460, the training elements, the test elements, and they sum properly. So it looks good. So this is all what we need to know about splitting the data into features, labels, and splitting the data into training and test data sets. If you need to know more about this process, I wrote 2 articles on my blog about it. The first one, how do I work with data using a machine learning model? And the second one is scikit-learn machine learning models in Python, workflow and introduction. So that's it for today. Happy learning and happy coding.